Hey guys, this is Sammy James doing week 7 of Interactive Advanced Concept for Gen Chem 1, Doane University. Let's get started. Alright, so we're going to go through electron domain geometry. We're going to start with, my example was boron trifluoride. It takes a trigonal planar shape, as you see here. It's a two-dimensional shape. It has 3 electron domains, 0 lone pairs, and it is a polar covalent molecule. Okay, so if we were to do molecular geometry for this one, it would be, the bent form, because we wouldn't count that 1 lone pair. So, and this would be bent form. Okay, so the next one is a tetrahedral shape for ammonia. Ammonia, is a polar covalent molecule. It's got 4 electron domains and 1 lone pair. So you see the 4 electron domains total. Tetrahedral shape. Okay. And then it would be trigonal pyramidal if we wanted to do the molecular geometry. That would look more like this one if we were to make it 3D. Okay. It would cut the number down to 3 because we wouldn't count that lone pair of electrons around the central atom. So that is ammonia. 1 lone pair of electrons, polar covalent molecule, 4 electron domains. There's the lone pair of electrons here, the 3 bonds to the central atom, nitrogen with hydrogens. Okay, next we have a water molecule, H2O. It will also take a tetrahedral shape. I went ahead and labeled that one. There was our ammonia with the 2 lone pairs on top. Here is our H2O tetrahedral shape. Water has 4 electron domains, 2 lone pairs, and its molecular geometry is actually a bent shape, and it is a polar covalent molecule. The bent shape, like we already saw, was here. The reason for the bent shape is because the lone pairs on H2O, the lone pairs of electrons have a stronger repulsive force, so they push those 2 bonded hydrogens closer together, and then the two lone pairs would be up in here somewhere, and then the 2 hydrogens would actually be down here, making that bent shape like an upside down V. Okay, that's for the molecular geometry shape. Next we have tetrafluoride. Sulfur tetrafluoride. It's a trigonal bipyramidal electron domain geometry shape. It's got 5 electron domains and 1 lone pair of electrons. It is a polar covalent molecule. Here is a trigonal bipyramidal, just like that. You've got the 5 total domains seen there. 1 lone pair of electrons, polar covalent molecule, like I said. There are the 5 total domains around the central atom, to include the lone pair up there. Okay. So next, chlorine trifluoride. This is another trigonal bipyramidal shape. Here we are, trigonal bipyramidal. This would be equidistant would look more like that. There we go. More symmetrical. Chlorine trifluoride has 5 electron domains, 2 lone pairs of electrons, and it is a polar covalent molecule. Okay. 28 total electrons. So this has 10 around the central atom, but chlorine is in the 3rd period, so it can have, it breaks the octet rule. So yeah, there were 28 total electrons there. You see 1, 2, 3, 4, 5 total domains. Okay, so next we've got another trigonal bipyramidal form. Okay, same thing. This one represents iodine difluoride. It has 5 total electron domains. 1, 2, 3, 4, and 5. 3 lone pairs of electrons, and it is a non-polar covalent molecule. Non-polar. If you see, you can see the non-polar covalent molecule, how the fluoride molecules on either end of the central atom are the same structures, same atoms. 22 electrons. Iodine can have more than 8 electrons, so there you see that taking place. Alrighty. 1, 2, 3, 4, 5 total domains circled, like we said. Alright, next we have a new shape to the game of bromine pentafluoride. That's going to be octahedral electron domain geometry for that one. It's got 6 total electron domains and 1 lone pair of electrons. 42 total. With these molecules, you really got to total out those electrons to make sure you get the right Lewis structure. 1, 2, 3, 4, 5, 6 domains. And we've got 1, 2, 3, 4, and then 5 and 6. Okay, so that was a tough one to make, octahedral in shape. And last but not least, we've got xenon tetrafluoride. It is a non-polar covalent molecule. It has 6 electron domains and 2 lone pairs of electrons. Like I said, another octahedral electron domain geometry shape, just like here, the last one. Okay, there you have it. And then let's see what xenon's Lewis structure looks like. It's a little challenging. 36 total electrons, and you've got 1, 2, 3, 4, 5, 6 total electron domains circled, and then those 2 lone pairs. See that right there? If we were doing molecular geometries, we would just take out the lone pairs around the central atoms. So technically this one would be a tetrahedral shape. Excuse me. It would be a square planar, because four atoms equidistant around the central xenon atom. And it would look something like this, just to give you an example. Square planar. Everything would kind of be flat like that. Square planar. Alright. Thank you guys very much. This was hard work, but I enjoyed this one. See you next time.